I am here to explain implementation of K-means clustering for customer segmentation. So in this code, we import K-means from sklearn.cluster. It initializes an empty list WCSS to store the within cluster sum of squares for each value of K. WCSS is the sum of squared distances between each data point and its closest centroid. So here we use loop to find optimal K. The for loop runs from 1 to 10 range 1, 1, 1, iterating through different values of K. In each iteration, it creates a K-means object with n clusters is equal to I, where I is the current value of K. The algorithm fits the model to the data, in this case data.iloc. Assuming the input data is a pandas data frame and the features used for clustering are in columns after the third index. Next we use the inertia. Inertia is a metric used to measure how well the clustering algorithm groups data points. Specifically, it is the sum of squared distances between each data point and the centroid of the cluster it belongs to. The lower the inertia, the better the clusters fit the data. For each value of K in each iteration of the loop, a new K-means model is created with a different number of clusters. After the model is fit to the data, the inertia for that clustering result is calculated. This value tells how compact the clusters are. Appending to the list, the calculated inertia for the current number of clusters K is equal to I is added to the WCSS list using the append method. Over the course of the loop, the list WCSS stores the inertia values for each number of clusters from 1 to 10. This helps in plotting and analyzing the elbow method graph. Plotting the elbow method. It plots the WCSS values against the number of clusters range 1, 1, 1. The plot is labeled with number of clusters on the x-axis and WCSS on the y-axis. The title of the plot is elbow method. The below code initializes a K-means model with 5 clusters, fits the model to the selected data, and then predicts the cluster labels for each data point, storing them in Y predicted. Adding cluster labels to data. The predicted cluster labels Y predicted are assigned to a new column in the data frame called cluster. In each data point is thus associated with one of the 5 clusters. Clusters 0, 1, 2, 3 or 4, separating data by cluster. The data is filtered by cluster label, creating separate data frames for each cluster. Each data frame contains only the data points belonging to that specific cluster 0 through 1. Scatter plot for each cluster. The code then plots each cluster on a scatter plot using plt.scatter squared brackets dot. The x-axis represents annual income and the y-axis represents spending scores 1 to 100. Each cluster is plotted in a different color: red, black, blue, green and magenta, and each scatter plot is labeled with the corresponding cluster number. Legend and title. A legend is added to the plot to label each cluster's color. The plot is given a title, customer segments, to indicate that the clusters represent different segments of clusters. This code visualizes the clusters found by the K-means algorithm based on 2 features: annual income and spending score. It creates a scatter plot where each color represents a different cluster of customers, allowing you to visually analyze the clusters formed by the K-means algorithm.